I want to talk about modeling. In this session, I'm going to explain the Conyers neighbors model. KNN is a classical machine learning algorithm. For big data, it doesn't work very well. It's not usually considered a very strong model, but if you look at it as a tool, it can actually be very helpful in many cases. There are two main methodologies for KNN that you can use, weighted vote and hard vote. In many cases, weighted vote is the more suitable route. Now let's run the code. Here I import pandas, seaborn, and matplotlib, and then I load my dataset. For simplicity, in this example, I fill any missing values with 0. This is not the most accurate way to deal with missing data, but it ensures that the dataset is clean enough to run the model. In real projects, more sophisticated techniques should be used. Now I define my features and target. Here X is my independent features and Y is my target, which is the column C. Next, I import neighbors classifier. Here, from the subpackage neighbors, I took neighbors classifier. To be note, almost all algorithms also have a regression version. Here, I set neighbors equal 7. I don't know if 7 is the best number or not, and I should tune it. For weights, I set it to distance, which means the strategy of KNN is distance-based. It can also be set to uniform, which means all the neighbors are treated equally regardless of distance. But here I choose distance-based. We have different kinds of KNN strategies. By default, in distance-based mode, it uses the standard Euclidean distance. So I create a KNN object with these parameters. Then I calculate the cross-validation score with 10 folds. And finally, I want the mean of their accuracy. If you don't write the weight argument, KNN behaves with uniform voting, basically by the most observed numbers. So for accuracy, as we can see here, the accuracy without cleaning, and we just fill it with 0, it is 64%. Now I import some more tools, matrix and train test split. Then I split the dataset into training and test sets. Now I want to tune the number of neighbors, the value of k. Usually in distance-based strategy, we can tune it by plotting different k values and checking the accuracy. So I define a range from 1 to 30 for k. It means it will show between 1 to 30, not 30, 1 to 29. Then in a loop for every I in car range, I do the three steps: initialize, fit, and predict. I just put n neighbors equal I. For weights, I accept the default, which is uniform this time. Then I use accuracy score from the metrics subpackage. For inputs, I give it y-test and y-pred, which are the reality and predict results or accuracy. Finally, I plot the results. On the x-axis, I put a car range, which is 1 to 29, and on the y-axis, I put the accuracy scores. This plot helps us see which value of car gives the best performance for our dataset. So thanks for your attention and see you in the next video.